Hey everyone, this is Remy, and this video is going to cover the Math 124 note outline for section 1.1, which is Introduction to Graphing. So first we'll talk about the rectangular coordinate system, sometimes called the Cartesian coordinate system, and basically it's the x-axis, which is horizontal, and the y-axis, and the x-axis increases left to right, and the y-axis increases bottom to top. And then it naturally is divided into 4 parts, and so we call this part the first quadrant, we call this one the second, this the third, this the fourth, and we usually denote the quadrants using Roman numerals like these ones, 1, 2, 3, 4. So you can put a point anywhere on here, and then of course it extends forever in all directions. So each point on the system corresponds to an ordered pair of real numbers x, y. So we have parentheses and then a number, comma, another number. The first number corresponds with x and the second corresponds with y. So if the x coordinate is positive, then the point is to the right of the origin. And the origin is this point here, right where the axes intersect. So this point here is 0, 0. That's the origin. And then if the x coordinate is negative, the point is to the left of the origin. And then if the y coordinate is positive, the point is above the origin, and if the y coordinate is negative, the point will be below the origin. So let's plot some points. Point A will be 0, -4. Point B will be 3, -3.5. So let's start with those. For A, the x coordinate is 0 and the y coordinate is -4. So the x coordinate tells you what to do left to right, and we always start at the origin. So since it's 0, we don't move left or right. And then the y coordinate tells you what to do down and up. So -4 means go down 4. So right here, that's point A. Now for B, this x coordinate is +3, so that means start at the origin and go right 3. And then the y coordinate is -3.5, so that's saying go down 3.5. So if I start here, I'm going down once, twice, 3 times, and then a half. Something like that. That's B. And then C is going to be -7, 2. So the first coordinate tells you what to do left and right. So -7 means start at the origin and go left 7. So that's here. And then the y coordinate is +2, so that means go up 2. So that's our C coordinate. And then D will be -3, 0. So the first coordinate is -3, so that means go left 3. And then the second coordinate is 0, so that means don't go up or down, just stay where you are. So that's D. So that's plotting points. Let's go on to page 2. Solutions of equations. Sometimes you're asked to solve something. Well, that means to find the solution to an equation. And for this section, we're going to talk about a solution to an equation that has 2 variables. So we're going to call the variables x and y. And so a solution to such an equation is a pair of numbers, a, b, in parentheses, which make the equation true when you substitute a in for x, and then also when you substitute b in for y, because a is in the x position and b is in the y position. So, for example, some solutions to this particular equation are negative 3, 18, and negative 1, 2, and 2, 8, and there's an infinite amount more. So we could go on forever and ever and ever and keep coming up with solutions to this. And so the reason why these are solutions is because if you plug in this value, the first value, in for x, and you plug in this value, the second value, in for y, it makes the equation true, because we'd get 18 equals 2 times negative 3 squared. And that's true, because negative 3 squared is 9, times 2 is 18, so 18 does equal 18. That's a true statement. Or say we plug in 2 and 8. Well, so the 8 goes in for the y, and the 2 is substituted in for the x. So is this a true statement? Well, 2 squared is 4. 4 times 2 is 8, so this is also true. So anytime you can find a pair, like a pair of numbers, and substitute them in for x and y, and it makes that equation a true equation, then that would be called a solution to the equation. So what about for 1? Is this going to be a solution to this equation? Well, let's see. We would have to substitute 1 in for y, so we'd have 1 equals 2, and then we'd replace the x with 4, and then squared. Well, is this true? Well, 4 squared is 16, times 2 is 32, so 1 does not equal 32. So this would be an example of something that's not a solution. So this is kind of an extra note. This is one example of a coordinate that's not a solution to that. Okay. And then these ones are, and we can think of a bunch more as well. Alright, so let's go to graphing now, which is the main part of this section. So the graph of an equation is a drawing that represents the solutions to an equation. So we just talked about solutions to an equation on the top of this page. So we would take all the solutions that we can find and plot them on the coordinate system, on the xy axis. Alright, so we're going to start off by talking about graphs that are straight lines. So say you have an equation and it's of this form, ax plus by equals c. When you plot all of its solutions on a graph, you'll get a straight line. So that's something to keep in mind, and we'll come back to that. And then the other thing we're going to talk about is x and y intercepts. An x-intercept is the point on a graph where the graph intersects the x-axis. So that makes sense, that the x-intercept would be the point that the graph intersects the x-axis. And then I'm going to fill this one in down here. The y-intercept then would be the point on a graph where the graph intersects the y-axis. And then note, the x-intercepts will always be of the form some number comma 0 in parentheses. And I'm going to go down here, the y-intercepts are of the form 0 comma b. Okay. And then how can we find what the x-intercept is? Well, if we already have an equation, to determine this a number, set y equal to 0, because y is supposed to be 0 here, and then you solve for x. Once you have that, that's what the number a is going to be. And then similarly down here, for the y-intercept, we want to find what b is. So to determine b, this time you would set x equal to 0, because we want x to be 0, and then solve for y. So in summary, to find x-intercept, set y equal to 0. To find the y-intercept, set x equal to 0. So let's do that on the next page, the top of page 3. So this is one technique to graph straight lines. First of all, notice that this equation here is in the form, we have the form ax plus by equals c. So that means if we graphed this, it should create a line. And we're going to use the technique find x and y intercepts. There's other techniques, but for now, this is what we'll start with. We just talked about how to find the x and y intercepts. We'll start with the x-intercept. So to find the x-intercept, we want to set y equal to 0. So that means in the equation. So I will get 2x plus 3 times 0 equals 18. And then I solve for x. Well, 3 times 0 is just 0, so that goes away. So I have 2x equals 18. Well, to get x by itself, I need to divide both sides by 2, so I get x equals 9. So the x-intercept is the point 9, 0. Now, let's find the y-intercept. Well, we're going to start over. This time, we're going to set x equal to 0. So we start over, look back at the original equation, and this time I'm replacing the x with 0. So I get 2 times 0 plus 3y equals 18. We're going to have 0 right here. Then we have 3y equals 18. So divide both sides by 3, we get y equals 6. So for the y-intercept, we have 0 for x, comma 6. So these are our, this is the x-intercept and this is the y-intercept. Alright, now when you're graphing, always remember to label. Label graphs. That means the x and y axis, put x here and y here. And then that also means you need to fill in the scale that you're going to use. So something like that. I put in some numbers, because if you don't put the numbers in, how does the reader know, if you're going by ones, or if you're going by twos, or threes, or fives, okay? So here I'm just going to go by, you know what, I'm not going to go by ones, because I have to go all the way up to 9. So let's go by threes. That makes more sense here. So I'm going to put 3, 6. See, this is exactly why we want to label. So you just need to go with a scale that makes sense. We could even have gone by twos. 2, 4, 6, 8, 10. Yeah, twos would have been fine as well. But I guess I chose to go with threes. And vertically, I'm just going to stick with ones, though. So horizontally, I'm going by threes, and vertically, I'm going to go by ones. Now, our goal is to graph this equation. Well, first of all, we know it should look like a straight line. Second of all, we found the x and y intercepts. So I'm going to plot 9, 0. That's right here. This is 9, 0. And then I'm going to plot 0, 6, which is here. And then I'm going to get something straight to draw my line in with. Alright, so I'm going to use my ruler, because I know that this has to create a straight line, so I can just draw the line through those 2 points, and draw it very carefully. Make sure you would go exactly through the middle of those 2 points. Okay. So we graphed that line. And what this line represents is if you choose any point whatsoever on this line, for example, say we choose this point right here. What point is this? This is 6, 2, it looks like. If I plug 6 in for x and 2 in for y, it should make this equation true. So let's check. 2 times 6 is 12, plus 3 times 2, which is 6. So 12 plus 6, that is 18. So no matter which point you choose on this line, it will make the equation true. And that's the entire point of what a graph is. All right, the technique we just used is plotting the x and y intercepts and then drawing the line through them. Now I'm going to do a different technique. So you can use whichever technique you want unless it's specifically stated, but sometimes some techniques just work better than others. So this will just be a different technique. So I'm going to solve for y, meaning get y by itself. So here I start with 3x minus 5y equals 10. I'm trying to get y by itself, so I need to subtract the 3x from both sides. So I get negative 5y equals negative 3x plus 10. So I've just subtracted 3x from both sides. And then y is not by itself yet. I need to divide everything by negative 5. I need to divide this side by negative 5 and this entire side by negative 5. So if I divide everything by negative 5, I get negative 3 over negative 5, which is 3/5 x. And then plus 10 divided by negative 5 is minus 2. Alright, so here we've solved for y. Next, create a t-chart. And we're going to plug numbers in for x and see what it gives us for y. So I'm going to be plugging values in here. So I want to choose easy values, values that will make the math pretty straightforward. So one easy number to plug in for x is 0. Because if I plug in 0 for x, I get 0 times 3/5, which is 0, and then minus 2 is minus 2. So y would equal negative 2 in that case. What would be another easy number to plug in for x? I'm going to go with the number 5 because I see it's in the denominator. And if I plug in 5 here, the 5's will cancel because I'd have 5 over 5. So those cancel, and then I'm just left with 3 minus 2, which is 1. So y would equal 1. Similarly, if I plug in negative 5, it's going to come out pretty nice. Because if I plug in negative 5, I have the same thing happening. The 5's cancel, but it's negative this time, so I have negative 3 minus 2, which is going to be a negative 5. So choosing numbers, choose, I guess, nice numbers to plug in for x. Okay, and then see what it gives you for y. And then you would plot those. So make sure you label x and y. And then also make sure you label your axes. This time I am going to go by ones on both axes. Okay, so I need to plot negative 5, negative 5. So here's negative 5, and then I have to go negative 5. So that would be right here. That's this point here. Graphed that. 0, negative 2 is right there. So graphed that one. And 5, 1 would be here. Alright, so I can tell that this is probably correct because if I connect these three, it will form a nice perfect line. Let's go ahead and do that. it created a nice line, which it should, because again, we are in that same form. AX plus BY equals C, so that should give us a line again. All right, and it did give us a line. So, two different techniques on this page for how to graph lines. The first technique at the top of the page, use the X and Y intercepts, and then the technique down here, solve for Y, and then plug values in for X to get your Y coordinates and plot those points. Let's go on to page 4. All right, another equation to graph, but this time, is this of the form AX plus BY equals C? No, it's not. This is not in the form AX plus BY equals C. In fact, this time the form is Y equals AX squared plus BX plus C, which is not a line. So for this one, at the moment in this course, our only techniques, if it's not a line, is to just plot points. Okay. So I'm just going to plug in a bunch of different numbers. I'm going to plug in -3, -2, -1, 0, 1, 2, and see what that gives us for now. So I'm going to do these relatively quickly. So if I plug in -3, I get -3 squared, which is 9 minus 9 times -3. So that's 9 plus 27, which is 36, minus 12 is 24. If I plug in -2, square it, I get 4, and then here I'd get plus 18, so 22 minus 12 is 10. If I plug in -1, I get 1 plus 10 is, or sorry, 1 plus 9 is 10, minus 12 is -2. If I plug in 0, this 0, 0, -12. If I plug in 1, I get 1 minus 9, which is -8, minus 12 is -20. And if I plug in 2, I get 4 minus 18, which is -14, minus 12 is -26. Okay, so that should give us a start to plot some points. Again, I'm going to start with X and Y. I see these numbers are going up pretty high on the Y-axis. So I think I'm just going to go by 5s. 5, 10, 15, 20, 25, 30. And then just to be kind of on the safe side, I think horizontally I'll go by 2s. Just in case I want to plot numbers that are a bit further out, because I don't know how this graph is going to look right now. Okay. So if I plug in -3, it gives me 24. So that's about, let's say that's about here. And then -2 goes up to 10. -1 goes up to, -1 goes down to -2. So this is -1. And so I have to go down to 2. So I don't know, maybe about there. 0, I go down to -12. If I'm going by 5s, that might be about there. And then plug in 1, I'm going to -20. So 5, 10, 15, 20. Right there. And if I nope, actually it's right here. That's not correct. Alright, so this is 1 and -20 would be there. And then 2, I have to go down to -26. So let's say that's about there. Well, this kind of looks like a line, but I think it's a slightly curving. So I don't know what's going to happen as I go this way. So let's plot in some higher numbers. I'll plug in 4, I'll plug in 5, I'll plug in 10. So if I plug in 4, I'll just tell you it's going to come out to negative 32. If you plug in 5, it's also going to come out to negative 32. And if I plug in 10, it's going to come out to negative 2. So I'm going to plot those. 4 goes down to negative 32, maybe there. And then 5 is also at negative 32. And then 10 is at negative 2. So something like right there. I have to mark over it. So it looks like the graph comes down this way and then comes back up and gets more points. So you could even plot more points to get a better idea. But for now, we're just really sketching. But once I plotted more points, I could get a better idea that it's going to look like this, especially because of this point here. It came back up to catch that one. So when you see a form that you're not sure of, then you need to plot a bunch of different points left to right so that you do get a good idea of what the graph is going to look like. Okay. All right. Now let's switch it up, and we're going to talk about the distance formula on the bottom of page 4.